Hi, this is Professor Sartor. I'm going to work a few examples using the rules that you see on the board here. The rules are involving natural log and e to the x. The rules state the integral of 1 over x dx equals natural log absolute value of x plus c, and the second rule is the integral of e to the x dx equals e to the x plus c. So we're going to work a few examples using these rules. The first example says the integral of 4 over x dx. We want to evaluate this integral using the rules that I stated earlier. And what I notice is that my problem is almost the same as the first rule here, integral of 1 over x dx. The only difference is that 4. With one of the properties of integration, called the constant multiple rule, we can pull the constant out of the integral. Like this. And when we pull that constant out of the integral, then our integration looks exactly like the formula. Then we're able to apply the formula, carrying the 4 down, and we're going to evaluate the integral to follow the rule, natural log absolute value of x plus our constant. The next example is the integral of 2e to the x dx. Once again, we're trying to use one of these rules over here, and we can see that this example matches the second rule almost exactly. So just having that 2 there is the only thing that doesn't allow it to match exactly. So we're going to use that constant multiple rule again, pulling the 2 outside of the integral. And then it matches the rule exactly. I'll carry that constant down and apply the rule. The integral of e to the x dx is equal to e to the x plus c. Now we're doing the plus c because when you find the integral or antiderivative, you're finding a family of antiderivatives. This next example is the integral of e to the x plus x dx. And what we notice about this example is having a plus. What we can do is apply a sum and difference property, and we can apply our integral to the first term and apply our integral to the second term separately, and notice that I've added these two integrals together because of the addition sign inside the integral. Now we can apply our rule for the integral of e to the x dx is e to the x. This integral here, the integral of x dx, doesn't fit either of the rules we're talking about here, so we're going to use one of our other basic rules. It's called the power rule, and we use that when we have x to a power. And to follow the power rule, we add 1 to the power and divide by that power. And we need our plus c for that family of antiderivatives. The next example is the integral of 1 over 5 minus 2 over x dx. We have separate terms inside the integral, so we're allowed to apply our integral to each term separately. So there's the integral of the first term minus the integral of the second term, carrying down that minus sign. On the first term, you have the integral of 1 over 5 dx. That is equal to 1/5 x. On the second term, we're going to pull out that 2 using the constant multiple rule. And once we pull out that 2, we have one of our rules exactly, the integral of 1 over x dx. And that's equal to natural log absolute value of x, and we need our plus c for the family of antiderivatives. In this example, I have the integral of x to the e plus e to the x dx. So we have separate terms inside the integral because of this plus sign. So first I will apply that integral to each term. The integral of the first term plus the integral of the second term. We carry down that plus sign. The first integral, integral of x to the e, follows our power rule. Our power rule is when we have x to a power. The power rule, we add 1 to the power and divide by that power. The second one fits one of the rules we're discussing. Integral of e to the x is e to the x. Adding our constant